Welcome to the introduction of LVM RAL Predictor. This presentation will go through the quick overview of this predictor, before and after using it, and its benefits. Besides, the detailed steps to integrate the predictor and the example integration will be shown as well. Basically, this RAL predictor is an enhanced version from the original UVM1, which is coded to be robust, easy to debug, and also user-friendly. Most importantly, it is totally free. Our objective is to help user to see the effect of bus transaction towards RAL in best detail, to migrate from hard-coded RAL programming to UVM register model write, and read style and to ease the firmware coding with info like address and data. Let's have a look at the original printing from LVM RAL Predator. As you can see here, for the read operation, the information available are just the register name and the read data. On the other hand, you can only get the register name, the incoming write value, and the final updated value after the write. With our RAL predictor, a read transaction will be expanded with much more info. Item number 1 here shows the register mirrored value before and after the read operation. Meanwhile, a useful and ready-to-be-used code for register read are printed as annotated Atom 2. Besides, a sample code for firmware is shown here. Not only that, the register field full map info are printed to let user know what is the address of the register. Each field bit positions, field full path, access type, reset value, and mirrored value before and after the read operations. In case the mirrored value is changed, it will be marked with an arrow sign. For the register write transaction, you will see the value before write, incoming new data with its byte enable value, and the final updated value. The code for register model write is given in set and update with a note on previous value. Just like the read transaction, full field info is printed as well. With our RAL predictor printing, you may easily observe how as a field get written throughout the simulation. For example, by gripping a particular field name and the arrow annotation from your log file, you will get the time and value that is written into that field, like the example here. In terms of UVM test bench cleanliness, we shall avoid the hard-coded address and data programming in our test case or sequences. These lines will be able to help user to migrate to register field access code in fastest, error-free, and most convenient way. To ease the firmware coding, which may be using hard-coded address and data, our predictor prints out the sample code that user can easily modify to fit into firmware code. Let's have a look at the steps to integrate this LVM predictor. In case you are already using our VIP, then it is already integrated. If not, you will have a few quick steps to follow as shown here. In your test bench says that you already instantiating the UVM reg predictor in your UVC. Then you can just touch up the code of predictor instantiation part to our LVM predictor. After that, the package file that include this class shall also include our source file. If your test bench only have register model and adapter, but not yet using predictor, then you will need to follow the step at previous slide, which is adding the LVM predictor source file into the class package that include the RAL adapter. After that, you just need to instantiate the LVM predictor at the class that instantiate the adapter and construct it at build phase, and connect it to your RAL adapter and your VIP monitor's output port during the connect phase. In our recommendation, User can choose base test as the class to instantiate LVM Predictor. As you can see, Predictor is connected to RAL that is constructed and also the UVC monitors port. LVM reserves the right to make changes without further notice to any product or specifications herein. LVM does not assume any responsibility for use of any its products for any particular purpose, nor does LVM assume any liability arising out of the application or use of any its products. At LVM, our mission is to enhance the performance and efficiency of design verification work in the industry by providing high-quality and low-cost AMBA VIP. To learn more about our services, please contact us at our email address. You can also visit our LinkedIn page to understand us more. Thank you for your time. Goodbye.